This is the introductory video for strings in C. Let's start off with the definition. A string is just an array of characters. You declare a string just like you declare an array of numbers. So for example, int values size 10. And if we want a string, well, we say char str buffer size 10. Notice that the prefix is str instead of chr, indicating an array of characters. Why? Because we want a string, not an actual array of characters. We are not storing a group of individual letters. We are storing a group of characters that are all related to one another, and they go in sequential order. As soon as we start writing some string functions, you'll have a better understanding of this distinction. When declaring a string, you can use the assignment operator in the declaration to assign an initial value. For example, char str buffer 50 equals I love Star Trek. The only time you can use the assignment operator to set a string variable equal to another value is in the declaration right here. It absolutely, positively will not work any place else. So for example, here I have the declaration, the assignment operator use is okay. Later on, somewhere in the code, I say str buffer. Notice the lack of the variable data type. So it's already been declared. I'm trying to assign something to it. If I try to change that to I love Star Trek and Star Wars, the assignment operator will fail. It will give me errors. Why won't that work? Well, let's use an array of numbers to help explain. So in this example, I say int values is an array of size 50 of integers, and I set the initial values to 2, 4, 6, 8, and 10. So the first 5 spots are guaranteed to be initialized. The last 45 may or may not, depending on the compiler. In the second line, I have char str buffer 50, so I'm making a string of size 50, and I set that to I love Star Trek, which is the equivalent of setting the first few values. Now later on, if I try to use the assignment operator with a group of values on my array of numbers, so if I say int values equals curly brackets 1, 3, 5, 7, and 9, that obviously won't work. I have to address each cell in the array one element at a time. And so the same thing goes with str buffer. For some reason, the designer of C made the assignment operator handle multiple values only in the declaration. It's just one of the quirks that we get paid to handle. How do we fix that? How do we assign a value to a string after the declaration? Well, the same way we handle values in arrays of numbers. So for example, int value size 50, and then we have char str buffer size 50. Now notice that I initialize the string to an empty string. There's nothing in it. So if I want to put values in my array of numbers, I say the array, and then I give an index, and then I set a value. I say the array, and then an index and a value, array, index, and a value. For string, I say string, element, and then value. Now notice that the letter is in single quotes. So that's whenever you want to enter a character value in, you have to enclose it in single quotes. Single quotes are for characters, double quotes are for strings. And so in the second line I say string, element, value in single quotes. That's a space. String, element, value. Yes, that is absolutely brutal, unbelievably tedious, but it was designed that way for control, so we really shouldn't complain. Using that logic, suppose we want to print a string. Let's do it the brute force way. So I say character str buffer size 50 equals I love Star Trek semicolon. And so then I'd say printf a character and then the element at spot 0, and then at spot 1, 2, 3, and so on all the way up to 15. Now I love Star Trek is 16 characters long, but it's 0 based. So it goes from elements 0 to 15. That's pretty tedious, but we could very easily loopize that. With a for loop, the code would look something like this. Again, we have our array declaration, and we get to use the assignment operator, but only in the to initialize in the declaration. Then we have our favorite loop control variable, which is in index, and then we have a for loop. It starts off 0 while it's less than 16. We go in steps of 1 and we print out the character one at a time. Notice we hard-coded we changed the hard-coded value to our loop variable in index. Now that works pretty well as long as we know the length at compile time. So when we're sitting down and writing this, as long as we know the length, that's going to work okay. Obviously, we aren't going to know the length of every string. Some could be read from the user or from a file, and we're not going to know all of those lengths at compile time. We need a way to find the length of a string during runtime. Before we get into that, I need to make sure you clearly understand the difference between the length of a string and the size of a string. The size is how big the character array is. The length is how long the content inside of the string is. For example, if we have char str buffer 50 equals I love Star Trek, the size of the string, the maximum size, the most it will hold, is 50 characters. The length is 16. That is the current number of characters or content inside that. Now, this is a very important concept and you need to burn it in your brain. Size is how big the array is. Length is how long the content is. We are going to have to be able to find the length of strings while the program is running so that we can do things with them. For example, print, concatenate, or whatever. So the big question is, how do we do that? There has got to be some way to mark the end of the content to indicate the end of the string. For example, we could use a period. So let's say I have I love Star Trek period. And then we could, using brute force code, we could say if the character element 0 is equal to a period. Now notice we are doing comparison. So that's the equality operator, equals, as opposed to the assignment operator. I'm sure you've been bitten by that bug at least once. So we say, is the first element equal to the character period? If it is, then the length is 0. If that's not, then we can check the next character. If the character's index 1 is equal to a period, then the length is 1, and so on. And we can do all that all the way up to 15, at least in this case for I Love Star Trek. Now we could very easily loopize that. Here's an example of that with a for loop. So we go from 0 to up to 50, and we check each element within index. If that's equal to period, if it is, we find the length, and then we break out of the loop. We stop. No need to continue searching. The problem with that is we could never use a period in any of our strings. So imagine how well a language would do if we said, hey, it works really well, except you can never use the period for any sentences. Wouldn't work very well. The designers of C were really smart. They knew that somehow they'd have to mark the end of a string and that they couldn't use any common letters like a period. So they decided to use something very practical and special. They used the null character, which has an ASCII value of 0. If you recall, the ASCII chart is a table that lists all the characters on the keyboard plus a few more special ones. If you actually bought the C book, if you turn to the very inside front cover, you will see an ASCII chart there. Each character in the ASCII chart has an assigned numeric value, which is called its ASCII value. For example, an uppercase A has an ASCII value of 65. So you can tell here I've taken a picture of that ASCII chart from our book, and if we look, we can see that the numeric value for an A right here is a 65 and B is 66. We learned that in the pyramid of letters. Wasn't that fun? Sorry if I brought any flashbacks or anything like that, post-traumatic stress syndrome. If we look up at here, we see that the ASCII value of 0 is the null character. Let me show you how to look that up if you are using the online book. So we switch over to Blackboard, we go to course content, and for our ebook there's the on-campus link and the off-campus link. I am currently off-campus, so I will click that link. Should bring me to the book here shortly. By the way, it's pretty amazing that we have this technology. This, just a few years ago, this was not available. So here's our book, and I'll just click on the copyright to get it started. And then I'm going to go to search, and I'm going to search for ASCII, A-S-S-C-I, and I go. And it gives me these results, and I'm going to open that in a new tab so it's easier to see. And I switch over there, and there is the ASCII chart. So you can look it up, you can read through it, it's pretty cool. So, and then there's a whole bunch of the operator precedents and a bunch of other things like that. But that is how you find the ASCII chart and the ASCII values using the online book. You could also just Google for it or use your favorite browser for it. All strings in C must end with a null value. So here's a brute force example of this. Now I want to make perfectly clear this is brute force. This is just an in-between step to get us where we're going. So I have character str buffer 1 size 50, and notice I use the ASCII values 65, 66, and 67. So that would be A, B, and C. And then the fourth value that I put in is an ASCII value of 0 or null. In the second string, I do the exact same thing, but instead of the hard-coded ASCII values, all I do is I just use the letter in single quotes. Now the compiler will automatically take care of translating that letter A into the numeric value 65, and the same for B and C. And it's got the numeric value of 0 for the null terminator. And so the strings are A, B, and C. Now, if that's in the declaration, if we want to use the assignment operator, and the brute force way, if we want to do that in code, we'd say element 0 equals 65, element 1 equals 66, element 2 equals 67, and element 3 equals 0. Right there is the termination. Another way to do it, instead of hard coding the values, is to use A, B, and C in single quotes. And instead of using the actual ASCII value of 0, we can use the escape character, which is /0. In fact, I could have done that right up here with my string buffer 2. I'm going to pause, and when I come back, that will be in there. So there you can see I put it right in there. That's the escape sequence. I tend to like just using 0 because it's a little easier on the eyes. I think the escape sequence is a little much, but you should pick one and then stick with it so that you're consistent. Now you need to study those examples so that you clearly understand the mechanics of what's going on. Why are we doing this? Because we must somehow mark the end of every string. And we have to use some sort of character that doesn't show up in normal English usage, like a period or semicolon or anything like that. So we have to use something that is not used in normal English. So we use a special character called null. Armed with that knowledge, we can modify our loop code to find the length of any string in C while the program is running. So for example, we have char str buffer 50 equals I love Star Trek, and we declare int index and length, and then we loop up to 50, and we say if the character at location in buffer sub index equals 0, so it's comparing ASCII values. If that is 0, then the length is equal to int index, and we can break. And so then we can go ahead and print that out. Now, string literals, that's anything in double quotes, for example, I love Star Trek, are automatically terminated with a null character for us. So let me give you an example of that real quick. See, I just put in the /0 up there. Anytime you have a string literal, that's something in double quotes, C automatically throws a /0 or a null character on the end for you. So you don't have to worry about that, but just with string literals. Now I'm going to pause and take that back out. Now, when you are counting the length or the number of characters in a string, you never, ever count the null terminator in the length. For example, the string ABC has a length of 3. You count just the characters. Now, by the way, the indexes of those characters are 0, 1, and 2. So the length is 3. That's actually the number of characters that you have. Wow, that's pretty cool, but it gets even better. Not only can we loopize the code, but we can functionize it. So for example, here's a function called string length, and it takes an array of characters, and notice we don't put the size in there, so it'll take any size string, and it returns an integer. And I'm missing int index, so let me pause and put that in there. So there's int index, got that in there now. We loop all the way up to 50 characters. If we find a null character, then that is our length. We can stop looping and we break out and we return the length. Whoa, that's incredible. But there's a slight problem. The stop condition is limited to 50. Now we could jack that up to maybe 500 or 5,000 or 50,000. But the problem is, as soon as we do that, somebody is eventually going to have a string longer than whatever number we put there. And we don't want to put something like 2 billion because that's just ridiculous. That's hackery, not quality coding. To fix that, we need to use a do loop because we don't know the stopping point. Remember, if you know the start, stop, and step, you want to use a for loop. If you don't know either the start, the stop, or the step, or any combination of those, you need to use a do loop. And we're going to use a pretest loop because the string may be empty. That means there's nothing in it. The very first character could be a null terminator. So we have our function string length, and it takes an array of characters, and we don't put a size in the definition or the procedure definition, so it'll take any sized array, which is really good and very useful. It returns an integer, that's how many characters are in there, and we use our pretest while loop, and notice we had to flip the logic. While it is not equal to 0, keep on counting. So until it will keep counting until it finds the null terminator. When it does, we'll go ahead and stop the loop, and then we will assign the index to length and go ahead and return that. And by the way, what's an empty string look like? Well, that's where you have char str buffer size 50 equals open double quote, close double quote. There's no space or nothing in there, so that is literally an empty string. Now, do we really need that extra variable for length in there? No, I just added it in for readability. Now, if I went around walking around in C-Town, I'd probably get beat up for doing that. In fact, I'm pretty sure of that. However, students love when I make the code readable. Here, let me show you a real quick example of how this C function is usually written. So here's the classic length function, the way it's written in C. That's a pretty stark contrast, isn't it? Hurts your eyes. Yeah, mine too. Anyways, that's how a lot of people write C. I don't recommend that. I recommend something beautiful like this. And you know what's really interesting? When it gets compiled down, they're both going to get pretty much compiled to the same thing. All the spaces will be stripped out. All the names will be stripped out. All the comments will be stripped down, and it'll be just mashed down into machine code without any extra. So it doesn't hurt to write it this way at all. Now we can take the same logic of using a while loop to look for the null terminator at the end of the string and apply it to other functions like printing. So let's start off with the brute force way of printing. We define a character array of size 50 and we set it equal to I love Star Trek. Now remember, a string literal, that's anything in double quotes, is automatically null terminated for us. So there's a /0 hanging out there. That's one of the rare things the compiler does for us. And then we march through each character time with if statements. Remember, this is the brute force way. And we compare each element to 0. If it's not 0, we go ahead and print it out. Now, we would need several thousand if statements to handle most strings. We could very easily, you don't say we read in a file, we read in the whole thing. So we don't want to have several thousand if statements. What we want to do is we want to loopize that, and we turn thousands of if statements into a single while loop. Here's the code using a single while loop. So again, we start off with our declaration and we say while, and the character at the current index is not equal to 0. Go ahead and print that particular character, increment our index, and move on. Now, that is really cool, but it gets even better. For a limited time only, if you are one of the first 15 callers, you can have the functionized version of this code. So let's say somewhere in main we declare str buffer size 50 equals I love Star Trek, and then we call print string, and we pass in the entire array. Down here in our code somewhere we have void print string. It will take a character array of any size. Notice we don't put a number in between the brackets, and we just have our same little loop code that will print that out one character at a time. Ooh, isn't that awesome? Now I realize you may be skeptical, so I copied the code into Visual Studio and I took out the comment blocks so it for the procedures so it all fits in one screen. Let's go ahead and run this and see what happens. And you'll notice, awesome, it prints out "I love Star Trek." And notice that press any key to continue is on the same line. Why is it all on the same line? Well, because we didn't tell it to go to the next line. Now, by the way, print string should not add an extra line to it. Oftentimes I see students that will do this. They say, well, a string should have a new line on it. No, that would be doing something for the user. Nuh-uh. If they want a new line in there, they will put one in themselves. Don't you go ahead and do it for them. So let's go ahead and try that out with our new line added manually. And there you go. Ha 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 ha. Awesome. Pretty cool, huh? We have code that will find the length of a string and print a string. We should probably write some code that will allow us to copy a string. Let's start off with the brute force way. Let's say we have two characters, source and destination. The brute force way would be to copy the first element in source into the first element in destination and continue to march all the way down the line up until n number of characters, however long that is. The problem with that is we need a whole bunch of assignment statements, and we never have enough because we never know how long a string might be. And we definitely don't want to put in just 2 billion lines just for the heck of it, because that would take up way too much space. There must be a better way. And as soon as we see it in this format, your brain should be screaming and shouting, "A loop!" That's right. And what kind of loop? Well, we do know the length of the string, or we could find out. So you may be tempted to use a for loop, but we probably want to use a do loop. And let's go look at that code. Here's the code with source and destination, and we're using a while loop. Now, how come we don't want to use a for loop? Because if we use a for loop, we have to check every character in the source looking for the zeros. That means we march through the entire array, one character at a time, and then when we find the zero, we stop and go back to the beginning and have to go through the entire source string all over again, this time copying characters one at a time. Well, that is inefficient. And remember, we're using C because we have limited resources. So if we use a while loop, in a pretest, we have to go through the source string only once, and we can do our comparison for null and do the assignment one character at a time. Now that works really well except for one small problem. Can anyone guess what it is? Well, let me give you a hint. What would happen if we called print string with str destination? So for example, I say print string strnation. Boom! Let's go find out what happens. So here we are in Visual Studio. Now I've taken out the comment blocks just so everything fits on the screen. You always need to use those. We got source and destination in index. We do our little copy, and then we call print destination, and then we have a pause. Now what happens when we run that? We get all kinds of gunk after "I love Star Trek." What is up with that? That should be our big clue there. When it goes to print, it keeps on printing one character at a time until it finds what? Yeah, that null terminator. And so when we did the copy, what did we not copy over? We did not bring over the null terminator. So in order to fix that, afterwards, we have to terminate. Oh. And we always want to comment that. Now we could do that one of two ways. We could use the actual ASCII value, or we could use the character escape sequence. I prefer the first one, a little easier on the eyes. Now let's go ahead and stop that and rerun. Bring that into space, and we get "I love Star Trek." Ah, that's exactly what was supposed to happen. So whenever we do a copy, we have to do the null terminate manually ourselves as well. So let me say that one more time, and with text on the screen so it's easier for you to follow along and burn it in your brain. The problem is we didn't copy the null termination character. We copied all the letters, but we did not mark the end of the string. And every string function in C looks for that termination marker at the end. When we go to print, it will keep printing characters until it finds a null terminator. Now we may get lucky and that could be the next character or in the string, or we could be unlucky and it might not be for several thousand characters, in which case it would print out a whole bunch of gunk like it did before. Now it's our responsibility to add that termination character after a copy. So for example, right here, here's the code. Let me give one more example of how that works in actual code. I'm going to comment out the termination, and I'm going to initialize destination to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So that's definitely longer than the original string. Let me bump that over so you can see. Now remember, anytime there's a string literal, it automatically throws a null terminator on the end. And I can simulate that by putting one in myself. That's the escape sequence of 0, but it's not necessary. So I've got 20 characters in there. Now when I go to run this and print, it's going to copy the source string over the destination. So I'll get I love Star Trek, and that stops at character 16, and then it keeps on printing until it finds a null terminator. Well, it didn't do anything after the K in Trek to the original destination. So that means 7, 8, 9, 0 and the null terminator are still left in that character array. So C happily went along printing a character at a time until it found the null terminator for the original string. Oh, very, very interesting. So that's how the mechanics, the underlying mechanics of strings in C work, and you're going to spend the next couple homeworks learning those details intimately. Bam! Let's kick it up a notch and functionize that. So we have void string copy with destination and source. Again, notice that we don't specify a size in the parameters, so it'll take any size array. We have our little loop. We keep on looping through. Oops, there's a bug in this code. Can anyone see what it is? Huge, massive bug. Anyone? Let me pause and fix that. There we go. I wasn't incrementing. So it would just keep on looping. That's what we call an infinite loop. Everyone gets bit by that eventually. You can tell that happens when you do. Your program just runs and runs and runs with no output. Let me go ahead and demonstrate that. So we're back in Visual Studio with the code, and notice here I have got the +1 commented out, so you could very easily just forget that. So programmers, we all make that mistake at least once or twice and get burned by it. The first time we get burned kind of bad, we spend about half an hour on that, then we then we promise we'll never do it again, and then we do it a second time and we get burned for like 45 minutes. We can't figure it out. Now sometimes we stumble across it. Other times we'll ask somebody for help, and like usually within 5 seconds they spot it and they're like, "Oh, you forgot to increment." And you get burned so bad you get a horrible scar from that you really never do it again. So here I've got that line gone. Now let's see the characteristic of what that produces when we run the program. So again, run a program, and what's happening? Nothing at all. And what it means is it's looping over and over and over. So when you get no output or anything, usually that means you're in an infinite loop. A good way to help debug that is you come up here to the pause button. You go ahead and pause, and you'll notice the current line is the yellow line. When we can inspect variables, we see that index is 0, so we step over that, and when we come back up, index is still 0. That should be our big clue right there that it's never exiting the loop. So how do we fix that? We go in there, we put in index plus equal 1. There we go. And now it should work correctly. And yes, we did. Back to the slideshow. Now C uses the variable names destination and source right there and there in practically every built-in string function, and so should you. A lot of times students want to use buffer 1, buffer 2. No, we got to conform to what the C standard is. And they always put destination first. For some reason, I would think it would be source and then destination, but nope, it's always destination and source. So to be consistent, in most of your string functions, you are going to use the parameters destination and source, and you'll put them in that order. If there's just one variable, most of the time you probably want to use source or buffer. So putting all the pieces together, we have something like main. We declare a string of size 50, set it equal to length, set our length equal to 0, and we copy a string literal into buffer. Then we go ahead and find the length of that. We print the length, and then we print the string. And oh, this is cool. You can pass not only variables to procedures, but you can also do string literals like this. So I can print this is the end and /n, and it works. Now remember, string literals automatically null terminated. So let's switch to the code and see what that looks like. I've got my prototypes for string copy, string length, and print string, and here is the code that I just copied and pasted in from the slideshow. Notice we call string copy, pass in the literal, I get the length, and then I go ahead and print it out the length and to prove it works, and then I go ahead and print that, and then I print the end. Now again, I don't have my procedure comment blocks just so this is more compact and it fits on the screen, but you should definitely have yours all the time. So when we're doing the string copy, we loop through the source, and while we're not at a null character, we copy over the character, increment, and then we terminate. And for the string length, we do pretty much the same thing. I got my little extra variable for length for readability, not required, but does help. And then finally we print one character at a time. So let's go ahead and run that, and it should run without blowing up. And it worked, flashed, went away, and that's because I didn't have a system pause in there. Let's go ahead and try that one more time. The length is 16. I love Star Trek. The end. Wow. Pretty awesome. You might be asking yourself, well, aren't there a bunch of built-in string functions that do all this stuff and more? Absolutely they are. They are all in the string.h library. But guess what? You can't use any of them. Why? Because this is boot camp. You can't use any of them until you understand how they work. I'll let you know when that is. So until then, you can't use any built-in string functions unless I specifically give instructions to do so. Now in the short term, that's going to hurt because you're growing. Remember, if it doesn't hurt, you're not growing. In the long term, that's going to make you a much stronger programmer. So most people complain about it for 2-3 weeks, and then they get over it, and then they develop a new and deeper understanding for appreciation for VB. Now, by the way, just to prepare you, it gets worse than this. When we start dynamically allocating memory and using strings and pointers, it's really going to hurt. So think of this as a warm-up to something much more awful. It could be a lot worse. As we have already covered, it's your responsibility to terminate any string. Most of your errors in the next few homework assignments will be because you forgot to terminate or you terminated improperly. Another thing that's your responsibility is to make sure you have enough space for whatever string you want to store. You can very easily run past the end of an array. For example, let's say you declare a character buffer of string array of size 5, and then you do string copy into that I love Star Trek. Well, the string literal I love Star Trek is 16 characters long, and you got to have one extra character for the termination. So you're trying to put 17 characters in a space that has just 5 reserved. So C will let you go past the end of the array. It assumes you're an expert, and if you want to go past the end of the array, it's because you wanted to. So let me demonstrate that. So we switch back to Visual Studio. We have our same code from before. We had buffer size 50. Now I'm going to make that equal to 5. And I go ahead and run that. And it appears everything is okay. Now, a lot of programmers come up here and they want to click the X to close that out. And if it does, the program does not terminate normally. It was canceled. Let's go ahead and run that, but this time press a space bar. Oh, look what happened. Runtime check failure number 2. The stack around variable str was corrupted. And you can either break or continue. So we go ahead and stop. Well, most programmers say, oh, that's fine. It didn't happen till the end of the program. Besides, if when you run it, you just click on the X, everything will be okay, won't it? Well, let's see how that works in practice. we're going to modify some of the code, and I'm going to put a variable int some very important value. We'll make it equal to, say, 42. So we've done that, and then we're going to have our string copier length, and we're going to print that out, and then we're going to printf the important value is %d/n, and leave space for that. Go ahead and copy that in there, and we're going to go ahead and run that. And we bring that into the viewport, and we get the length is 16. That's correct, and prints out I love Star Trek, and it says the important value is 0. What? How did that happen? It was 42. Well, oh, and then we get our memory corruption error. When we copied 17 characters, if we include the null terminator, into our buffer of size 5, 17 minus 5, those 12 extra characters had to go somewhere. So let me bring up Excel to show you what that actually looks like in memory. So imagine if all the memory in your computer is like a giant grid in Excel. It's pretty close to how it works. Not quite, but enough to give you a good idea of the process. Now, when the computer starts up, Windows runs, and it grabs that first hunk of memory. It owns all of that. Nobody else can touch that. And then every time you run a program, it gobbles up another hunk of memory. So your browser takes a chunk, your MP3 player takes a chunk, and your program that you're writing in C takes a chunk. Now, if we zoom in on your particular program, when it loads into memory, it is split into two pieces. The first piece is all your variables and your data, and your second piece are all your functions and subroutines. Now, why does it do that? Well, that's a long, involved question. There's a great book called Compiler Writing. It's called the Dragon Book. You could investigate that, but that's a long journey. Anyways, just take my word for it. It's easier this way. So when your program loads in memory, it splits it up into two pieces, variables and memory. Now, if we zoom in on that, and we look at how your program is in memory, every time you declare a variable, it takes some hunk out of the memory allocated for your program. Now, as you recall, back in our original code, so let's switch back to that temporarily, we had three variables: int, some very important variable, str buffer, and length. So let's go back to Excel. Now, you notice that the physical order in memory is the reverse of the declaration order. So length comes first. Now, length is an integer, and that takes 1, 2, 3, 4 bytes. So let me zoom in on that. So it takes 4 bytes. Now, for buffer, each character takes 1 byte, and we declared 5 of those. So 1, 2, 3, 4, 5. And finally, some important value, and that is an integer, and that gets 4 bytes along with it. Now, when we copied I love Star Trek into str buffer, it put an I in spot number 5, a space in spot number 6, an L in 7, an O in 8, a V in 9. Now, at this point, if you were in VB, Visual Basic would say, "Oh, kind sir, you have gone past the boundaries of your array. Here, let me get you some more." And it would scooch over some important value and make space for it. C, on the other hand, says, "Oh, this should be pretty good. I wonder what's going to happen." It will just keep on writing, and it'll put the E, and then the S, and the T, and the A, and the R, and then the space, and the T, and the R, and the E, and the K. So, oh, and then it puts your null terminator. So whatever is in memory after the string will be overwritten. Here, let me zoom in. Let me do any more zoom. Nope, that's it. So that's why some important value got nuked. Now, why that's showing up as 0, oh, I'm sure there's a very good reason for it. not even going to look into it. But the danger is when you go past the ends of your array, you wipe out other data. Now, if we're lucky, there was nothing past that. If we're unlucky, like in this case, it wiped out some important value. Now, there's all of these things called buffer overruns attacks, and what they will do is they will deliberately load in an extremely large value, and they will keep on doing that until they fill all the space allocated for the variables. Now, how do they do this? Well, because they're hackers and they spend a lot of time in that. And they not only run past all the data area, but then they run into the procedure area. Now, if you're very crafty and malicious, you can send data that basically you write your own procedure code, and you can have it do whatever you want. And that is called a buffer overrun attack. Or vulnerability, and you see a lot of patches for those, especially in Internet Explorer a while back. Those are very common. That's how somebody, if you went to a website, they could compromise your machine and install a Trojan or a virus on it. So wow, we learned something important. So the moral of the story is, it's up to you to make sure you have enough space for whatever strings that you want to store. Otherwise, C will happily let you drive right past the end of your variable and go into whatever is left in memory. So you must always make sure your string is big enough for both the contents and a null terminator. So in this case, for example, I say str_buffer1, I give 5 characters, and I put that A, B, C, D. That's bad because there are 5 characters plus 1 terminator. That's 6. It will overwrite what is in memory. If on the second example is good, I have 6 characters, I put 5 in and 1 for the null terminator. Now you may be thinking, the more I use C, the more I like VB. Well, that's definitely my case. I appreciate the language and I have a great deal of respect for it, but it is not my favorite language to program in because it is so tedious and so demanding. Other languages take care of all this stuff for you, but at the cost of more CPU cycles, more memory, and more hard drive space. So there is a trade-off for all that stuff. Summary. Strings are an array of characters. Size is how big the array is. Length is how long the contents in the array is. A string must be terminated with a null ASCII value character 0, and it's your responsibility to make sure all strings are terminated and that the size of the string array is large enough to store the contents and a null character. And until further notice, you cannot use any built-in string functions. So that is the end of the Introduction to Strings video. Next up is a homework.